Hello everyone. Today we are going to see the next topic from the hidden surfaces, that is unit number 4, and the topic name is Z buffer. So in the previous lecture we have covered the introductory part of the hidden surfaces. In that we have seen that how we are going to find out the back faces, and the process of removing such a back faces is called as a back face removal. Whenever we are identifying back faces and we are removing them, then this technique is called as a hidden surface problem. So we have seen that concept. Now we are going to move towards the algorithms that are used for this hidden surfaces. So whenever we are defining any algorithm for calculating the hidden surfaces and removing such a surface, the widely used technique is nothing but the depth comparison algorithm. So whenever we are measuring any coordinate system for the 3D coordinates like in XYZ, so X worked as a its width, Y works as a height, and the Z works as a depth. So in the depth comparison algorithm we are using the depth coordinate. Depth coordinate is nothing but the Z coordinate. So we are going to compare a Z coordinate of that object to find out whether it will be a hidden or it will be a visible. So the name is depth comparison algorithm. So this technique of comparing the depth of object or comparing the Z coordinate of object is widely used, and for that purpose we are first going to see what is the depth comparison algorithm, and then we'll move towards the Z buffer. So the depth comparison algorithm actually is the concept that is used for an hidden surfaces algorithm. So here it must be capable of finding the edges or the surfaces which will be visible or which are not visible. So for that we are having this diagram over here. In that it is mentioned that two points we are having, that is A and B. The coordinates of A point is x1, y1 and z1. The coordinates of B point is x2, y2 and z2. Now here we want to find that which point is hiding to another point, whether A is hiding to B or B is hiding to A. So whenever we are doing such a thing, that whether point A is hiding to point B or vice versa, we have to go through some process to find out such things. So how we are going to find that? So if we are considering the first diagram itself, so here you can see this is what the A coordinate, this is what the B coordinate. A is having its values as x1, y1, z1, and B point is having its values as x2, y2 and z2. We are having the coordinates value in terms of 3D coordinate system. 3 values we are having. Now whenever we want to see that which point is hiding to another point, means how we are going to find out that which point is hiding another point? Whenever you are looking from one particular point, that is viewing point, then which object you can see, which part or which surfaces of that object we can see, and due to that surfaces many of the other surfaces of other object may get hide. So whenever we are looking towards any 3D object, and if we want to plot that, so we are plotting them into the 2D. So what I am checking, that whenever I am plotting such a 2 points from a particular viewing point, suppose this is my viewing point, then which point will be visible? So it is same like engineering graphics, top view, front view, likewise. So which point is visible to our eye, that we are only going to plot. So how we are going to calculate the visibility of that point? According to their depth. So we are going to compare the Z coordinate over here. How? Let's see. If both points A and B are not lying on the same projection line, so this is what the projection, if I am viewing this point from this viewing point, okay, so this is what the projection line from that viewing point. So whenever we are considering that two points are not on the same line, they are not a collinear, they are not lying on the same line, same projection line, then no point will hide another point, means both points are visible. So if I am looking this point from this side, so I can look B also, I can look A also, okay, I can see both the points. So because they are on different projection lines, so these are the different projection lines are here drawn, and the both points are on the different line. So it means that if both points are not a collinear, then both will be visible, and therefore we have to take the projection of A and B points on the xy plane. So you can see that first of all we have represented our point A and B in the 3D plane. Now whenever we are going to project that point, so always we are going to project them into the 2D plane, that is XY plane. So whenever we are displaying such a 2 points over here, then both points are visible because they are not on same projection line, and that's why the 2 points are drawn over here. They are projected on this XY plane. So what will be the coordinates now? Because Z coordinates is removed over here from this A and B, so coordinates of A will be x1, y1, and coordinates of B will be x2 and y2. So in this way we are going to find out the points, or we can display or project the points which are not lying on the same projection line. But what happens if the point is lying on the same projection line? That we are going to see. So see here, if both points A and B are lying on the same projection line, okay, here is our point A and B, and they are lying on the same projection line. So here is our projection line, right? Now if we are considering that these are the point A, this is the point B, okay, A is having its coordinate x1, y1, x1, y1 and z1, B is having its point x2, y2 and z2. Now I am looking from this point of view, I am looking toward this point B and A. So I will come to know that the one point is hiding to another point, right? So one of these 2 points get hidden by the other point. So as both points A and B are collinear, the projection of both points in the 2D plane, that is XY plane, will be only a single point, means only one point we can see at a time, because the another point is hidden due to the one point. So whenever I am saying I am looking from this point, so I will look a B, and due to this B the A gets hide, so that's why we are putting the B point in our XY plane. So how we are going to recognize that concept, that whether we want to display B or we want to display A? So for that purpose we are going to compare a Z coordinate, that is a depth of that particular object or a point. So how that we are calculating, I will explain you later, but the thing is that if we are plotting this x1 and y1 or x2 and y2, the value of that will be a same, and you can see here the B is very near, the Z coordinate of this B is near to the viewer, because the viewer is on the Z axis, right? So we are just going to measure the Z coordinate. So by looking at a Z coordinate, this Z is near to the viewer than this Z1, Z2 is near to than the Z1, and that's why we are taking this B as a displaying point on this screen. So for that purpose, that third parameter we are using is nothing but the Z coordinate, and that Z coordinate is acting as a depth. So if the Z coordinate of a point A, that is Z1, right, this is what the Z coordinate of a point A, Z1 is smaller than the Z coordinate of a point B, that is Z2. So if Z1 is smaller than Z2, means Z2 means B point is hiding to A point, means B point should be displayed whenever your Z2 value is greater than Z1 value. Because this A is in the negative direction, B is in the positive direction, that's why Z2 is greater here than the Z1. But if the condition is vice versa, means the Z1 is greater than the Z2, then we have to say that the A point is hiding to the B point. So this is what the complete scenario of a depth comparison, where we are just comparing the Z coordinate to display. So here we can easily say that the Z2 is a greater, right? Here we can easily say that the Z2 is a greater than the Z1. Why? Because it is on the positive axis, it is on the negative axis, right? So Z2 is greater than Z1, and that's why we have to display the B point, because this Z2 is near to the viewer and B is hiding to 8. So I have put it here the B point with the coordinate x and y as x2 and y2. So this is what the depth comparison that we are going to use in our further algorithm. So now we are going to start with the Z buffer. This is what the one algorithm for finding out the hidden surfaces and removing such surfaces. So it is the way of finding out or handle the hidden lines and the surfaces in the Z buffer. So if we are talking about the buffers, before this we have seen the frame buffer, right? So we are going to use somewhat similar concept related to the frame buffer, like a Z buffer, means we are going to store something in that buffer. So very first thing that we are going to do is that we are sorting the polygons. Polygons is nothing but it is made up of different lines, so we are sorting them according to their position in the space, Okay, according to their position we are going to sort them. Then in the frame buffer and then in the frame buffer itself we are storing the polygons which are closest to the viewer, means we are going to use the frame buffer also and Z buffer also. So in the frame buffer we are storing the polygons which are closer to the viewer. So the polygons which are closer to the viewer, that are stored into the frame buffer. Now frame buffer is used to store the images which we want to display on the monitor, means only those edges will be there, that those lines will be lie there, that we are going to display on our display device. And for the visibility test, means which are the visible and which are the invisible, for that visibility test we are going to use the Z buffer. So which concept we are using in the Z buffer? Both frame buffer and Z buffer. First of all we are sorting our polygon according to their position in the space, and then we are going to store the lines, those are visible only, that lines we are going to store into the frame buffer. And to find out the visibility whether they are visible or not, for that purpose we are going to use the Z buffer along with this frame buffer. So this is what the technique that we are going to use here in the Z buffer. So let's see how we are going to do that. So the Z buffer is a large array to hold all the pixels of the display. So Z buffer is somewhat similar to the frame buffer, means both the concept we are using and the one is somewhat similar with the another. So in the frame buffer we are having the arrays to store the x and y coordinates of an image. So we know the frame buffer concept. What is the frame buffer is that in frame buffer we are storing the commands like move and the line. These are the two commands we are storing into the frame buffer. Move is denoted as an operand 1, opcode is given to the move command as a 1, line command is having its opcode as a 2, and we are also storing with this opcode, we are also storing an x and y coordinate with that, that is x operand and y operand. So this is what the structure of frame buffer, which is nothing but a grid, which is nothing but a array that will store the x and y coordinates of the pixel. So similarly the Z buffer is also contain the Z coordinate. So as we are storing the x and y coordinate into the frame buffer, we are going to store the Z coordinate into the Z buffer, which we want to display, that coordinates are we are going to store into the Z buffer. So it helps to sort the polygon by comparing their Z position easily. So we can compare the Z position or the depth comparison from the Z buffer easily, and then we are going to sort that polygons. So in the simple terms, it will keep a track of the nearest Z coordinate, that will be a nearest to the viewer, the nearest Z coordinate of those points which are seen from that a particular viewing point x comma y. So that from that point we are going to calculate the distance which will be a nearer, that will be selected as a nearer point, or that can be find out as a point which should be displayed. Okay, so with that when there is nothing to the display on the monitor, that is the frame buffer is totally empty, at that time we have to initialize, means whenever our x and y coordinates are not displayed, our frame buffer is empty. So what to do about the Z buffer? So in that case our Z buffer elements are set to the very large negative value. Whenever there is nothing to display means x and y coordinates are not there to display on the display devices, and our frame buffer is totally empty, at that time what we have to do with the Z buffer? So our Z buffer is set to the very large negative value. A large negative value on the Z axis represents a point which is beyond the point beyond which there is nothing and setting background color, means that nothing is a point there going to display. Large negative value is means nothing but a point beyond which there is nothing to display, and that at that time we are setting our Z buffer value with the background color. So how we are initializing that? Z buffer of x and y is equal to the Z of initial. Now it may happen that it looks strange, like we are writing it as a Z of x and y. So this Z is not showing the Z coordinate, but it is a Z buffer. This Z is nothing but a Z buffer, and x and y are the coordinates. So sometimes we are writing that Z of x and y. So it doesn't mean that Z coordinate, x coordinate, y coordinate. It stands for the Z buffer. So Z buffer value of x comma y. Okay, Z buffer value of coordinate x comma y is equal to initial Z initial, means we have set it as a background color initially. Then polygon will be entered one by one into the frame buffer. Polygon is entering into the frame buffer, only its z value will be stored into the z buffer. This we have to keep in mind. The frame buffer, z buffer are the different thing. Frame buffer is going to store only x and y coordinates, z buffer is going to store an z coordinate. So whenever we are storing a polygon one by one onto the frame buffer by the display file interpreter, during this process each of the pixel x comma y that lies inside of the polygon, then we have to calculate that for each pixel x comma y we have to calculate its z buffer value also. Means what? The polygon is made up of 3 lines. I want to store that 3 line. I am going to store that line onto the frame buffer, but while storing that line onto the frame buffer, for each line I am going to calculate its z value also. Means while storing the 3 different line, we are going to calculate the 3 different z values, and according to that particular point z of x comma y I am going to store. Means one line is having the 2 points, 2 endpoints. So for each point we should have to store the z value also. Then we have to compare the z position of that polygon which with z buffer of x comma y value, and then we are going to decide the new surface which are in the front and which are in the behind of the current contents of frame buffer. So we are always going to compare it with the frame buffer. Z comparison we are going to do over here. So if a new surface, whatever we have included in our z buffer and frame buffer, if that new surface has the z value greater than the z buffer, means the initial z buffer value is set to the z initial. Okay, and now if I am included one surface over there, and if I found that the z value of that surface is greater than the z buffer value, then that surface lies in front. So we have to modify a content of the z buffer with that new surface. Okay, with that new z value, and we are setting the pixel value of x comma y to the color of the polygon at x comma y. So you can see here in the coding part it is given that if z value of any particular point that I want to store is greater than the initial content of the z buffer, then we have to update the content of z buffer, like z buffer of x comma y is equal to z of x comma y. Means the content of z buffer is now set to this new z value because it is in front. Okay, so this z buffer contents we have stored here in the z buffer x comma y, and after that we are put pixel, means we are coloring, giving the color of a polygon to that pixel. Initially we are set a z buffer to the color of background. Whenever we are inserting and that polygon surface is in the front, then we have to set the color of z buffer with the polygon color, not to the background color. So in this way we have changed a value of a color as well as we have changed the value of z buffer. Means we have pointed out here the nearest z coordinate. If we are setting such a value, means the z coordinate is nearest z value, and now I have stored that nearest z value into the z buffer. So whenever I am getting a next point, at that time we are going to compare the next point value with this z buffer value. Okay, so if the z value of a new surface is smaller than the z buffer value x comma y, if a z value of the new calculated surface is smaller than this z buffer value, then that surface is nothing but they are lying behind, they are not in the front, they are lying behind of the some polygon which was previously we are entered. So the new surface should be hidden and we have not to display, so we are not going to include that value, we are not going to update that z buffer value. Okay, so the frame buffer and the z buffer should not be modified here, both will be remain same because its z value is smaller than the z buffer value. So if such a thing happens, when that surface are hidden, if its z value is smaller than the z buffer value, then the surface is hidden, otherwise the surface is visible. So this is what the comparison we have to carried out with respect to the z buffer. So what are the advantages and the disadvantages we are having with this z buffer that we are going to see? So advantages is that it is very easy to implement this z buffer. Okay, in this z buffer algorithm process, one object at a time, we can have the number of objects can be very large because we are going to store the one atom at a time, and it does not require any additional techniques. We are just comparing the z value, so no additional technique will be required. What is the disadvantage of this z buffer? It requires the lots of memory as we are storing each pixel's value, so lots of memory will be required over here in the Z buffer, because we are storing each and every point in terms of Z coordinate also. So large memory is required because we are using two buffers, Z buffer as well as the frame buffer, and it is very time consuming process as the comparisons are very much, because every time we need to compare with the Z buffer value. So these comparisons are very much due to each and every pixel get compared with the Z buffer value. So these are the advantages and the disadvantages we are having with this Z buffer. Now to understand the algorithm, we can understand this concept by taking one example here. Now suppose there are 2 points are there, A and the B. 2 points we are having here, A point and the B point. A point is having its coordinate as x1, y1, z1. B point is having its coordinate as x2, y2 and z2. Now if we are considering these points over here, then we are going to check which point should be displayed onto this coordinate system, whether the displayed point will be A point or it will be a B point. So for such a comparison, we don't know which point get displayed. Okay, so for that comparison we are going to check here. See, if x1 is equal to x2 and the y1 is equal to y2, then in 2D we can represent this point by the single location as shown in the figure. Means both x1 and x2 values are same, y1 and y2 values are same, then both points will get displayed on the display device. Now we can use the Z buffer algorithm to check the visibility, means which one will be visible, whether B visible or A visible. That visibility test we are going to make by using the Z buffer. So let's first check the point B. So we are going to check for the point B, and I will find out what is the Z value of point B. That is nothing but the Z2. So I will mention that the Z buffer value of x2 comma y2 means B point is nothing but the Z2. Now we are going to compare with that Z buffer. What is the value in the Z buffer that we are going to compare with the Z2. So Z of x2 y2 with the Z buffer we are going to compare, but the Z buffer x2 y2 is initially, because nothing is stored in between that, so initially its value is set to the very large negative value. So whenever we are comparing that Z2 with the very large negative value, then surely the Z2 will be greater because it is very large negative value, and this Z2 is going to be larger than this large negative value. So Z of x2 y2 is greater than Z buffer of x2 y2. Initially in the Z buffer we are having the large negative value, and Z of x2 y2 is nothing but our Z2 coordinate. So Z buffer of x2 y2 is now updated with this new coordinate, that is Z2. Why new coordinate? Because it is greater than the Z buffer value, it is greater than, and that's why we can say that the Z2 is in front, and that's why we have setted this Z buffer value with this new value Z2. Now after that we are going to check for the point A. So for a point A, what is the value of Z value of a point A? Z value of a point is nothing but Z1. So we know that Z of x1 y1 means this is what the x1 y1. So what is the Z value of x1 y1? Z1. So we are going to check that with the Z buffer value. Now what is in our Z buffer? In our Z buffer now we are having a Z2. Initially we have the large negative value, but now that large negative value is updated by the Z2 because Z2 is in the front. So we are going to compare that, and here we are going to assume that Z1 of x1 y1 is equal to Z2 of x2 y2, because we are saying that x1 y1 and x2 y2 are same and both points are same. So we just need to compare that Z2 and Z1. So which point will be in the front? So here we are going to compare that Z2 is greater than Z1. Okay, Z buffer is set to the Z2 at the time of point B. So we have to compare this Z1 and Z2 because Z buffer contains Z2, and now I am going to compare with the Z1. So this Z2 is greater than Z1. How? Because they are on the negative axis. If you are calculating that, then Z2 is near to the viewer than the Z1. Z1 is far away, Z2 is near to the viewer. So Z2 is greater than Z1, and that's why we are not storing that Z1 into the frame buffer, and Z1 is behind and Z2 is in front. So we can say that the point B, x2, y2 and Z2 is in the front to the point A. So point A is hidden, and so there is no need to draw the point A as it gets overlapped with the point B. So only you can show here the point B. No need to show the point A because it is behind point and B is in front of A. So in this way we are calculating this values of Z buffer, and according to this value we are going to calculate the back faces and the front faces, and we can remove that back faces according to their depth comparison. So what kind of questionnaires can be asked here, that how the depth comparison algorithm used to find the hidden surfaces. So we can draw the diagram that when the points are not lying on the same projection line, and another when the points are lying on the same projection line. By showing these two comparison, we can show there by calculating the depth, means by calculating the z coordinate which is near to the viewer, that should be displayed, which is far away for the viewer, and hiding by the single point, then we have not to display that point. Then the next question is explain the z buffer algorithm and its application we have to explain. Then explain the z buffer algorithm and write a short note on the z buffer. So these questions are repeated. Such a questionnaires can be asked on depends upon the topic z buffer, which is nothing but the algorithm for finding out the hidden surfaces. So with this concept we are stopping today here. Thank you all of you. Thank you very much.